This right here is the equation for the general theory of relativity. It's possibly one of the most important equations ever made. But what's interesting about it is it did not start out as one equation. It actually started out as 10 different equations that were all combined together using one principle, the cosmological principle.
But what even is the cosmological principle?
Well, to explain, here are some Legos. Now let's just imagine that each of these bricks represents a galaxy of around 300,000 to 3,000 light years across.
And now let's take all the bricks and place them in a basket and then randomly shake them up.
Alright, then we're going to take the basket and divide it in half. And then we're going to take the two divided halves and weigh each of them separately. As you can see, that is 344. And then we're going to do the same thing for the other half. As you can see, 344.
So now you can see both halves have about the same mass. But what's interesting is both halves are almost completely different. I mean, look at over here. You have smaller, thinner pieces connected together. Well, over here you have a bunch of separate blue pieces that are pretty large. But in the end, both halves have the same mass.
But how does this experiment relate to the universe in general? Well, as the experiment showed, when we zoom out of perspective, variables like mass sort of become irrelevant. Like in the experiment, when we zoomed out, all the Legos mass, even when we divided it in half, became the same. And this also happens at the universal scale too, and that's basically what the cosmological principle is saying. At the widest universal scale, about at 100 million light years, stuff like mass, speed of particles sort of becomes irrelevant. And by using the cosmological principle, Einstein was able to cut down on variables and turn 10 equations into one.